You. Welcome to another episode of Black Guy Does Physics, where we're going to try and attempt to do a problem fresh. Haven't seen this problem before, haven't looked at it, no nothing, no prep. Just to put myself in your shoes and see what happens. Hopefully it doesn't suck. All right, with that being said, remember, smash that button. Okay, and leave a comment or whatnot. If you need some help, just holler at your boy and I'll try and help you out, okay? With that being said, let's get cracking. First things first, as always, you want to look at your diagram. So when I look at this diagram, I see, oh, this is collision, bruh. So collision is easy, man. That's just momentum. So with momentum, what I always tell my students is that you always want to think about impulse also. Because the momentum and the impulse are related. We know that momentum is the conservation of momentum. M1 V1 plus M2 V2 equals M1 V1 prime plus M2 V2 prime. You get that jump. The impulse is a tricky one. The impulse is equal to the change in momentum, but it's also equals to F times T. So you could finesse that some other way. So momentum problem, that's all that is. I think I've seen something similar to this. Yes! Broski! I gave my kids some homework like this junk. Oh, snap. Yeah, clay stick, rubber ball, it's going to bounce. I swear, I'm pretty sure they're going to ask you, like, yo, which one had the greater something. And the answer is it's the rubber ball. It's so easy because I gave these kids, oh, look at me being an awesome teacher. Student has a piece of clay and a rubber sphere, both of the same mass. Both objects are thrown horizontally at the same speed, so they have the same speed. Identical blocks at rest, so momentum of the block before is zero. Friction, not going to have any, I'm pretty sure. After collisions, both blocks fall to the floor. Oh, crap. So if they fall to the floor, there could be some projectiles. So that might be some projectiles here. That might be some projectiles. Okay, cool. All right. In case A, the clay sticks to the block after the collision. In case B, the rubber ball bounces off the block after the collision thingy. So, all right, cool. In the figure at the left above, don't judge me because I can't read. The arrow represents the momentum immediately after the collision for the clay block system in case A. In the figure right, draw an arrow starting on the dot to represent the momentum of the sphere block system immediately after the collision in case B. If the momentum is zero, write 0 next to the dot. The momentum, if not 0, must be represented by arrow starting on and pointing away from the dot. The length of the vector, if not 0, should reflect the magnitude of the relative case of in that. So, it's let's see, they should have the same impulse, right? They're gonna have the same impulse. This one is gonna have this momentum. This one is gonna have this momentum. The block, and I think this should be 0, man. I think it's just 0. The total momentum. They're talking about the total momentum here. Because one is going to shoot off this way and one is going to shoot off this way, right? So this one is going to give the block, the rubber thing is going to hit this one and give off some speed there, and this one is going to give off some speed. But if you look at it in terms of the impulse thingy, what's supposed to happen is that this impulse, when it hits and rebounds, they should have the same amount of impulse this way and the same amount of impulse this way. So hopefully it's 0. If not, then because they didn't give you any the masses of the thing, so otherwise you can't really tell. You know what I'm saying? Can't really tell. So I think it must be 0. If I'm wrong, hey, kids, this is me being a mumu. Yes, do not be a mumu. Apparently, momentum is conserved. Whatever momentum you start with is the momentum you end with. Really? Yes, it is. So, therefore, it's just the same arrow. I just get excited because I was like, yo, I've seen this thing before. We did it before. But you could see that's a trap that you could do. And once again, just don't be a moo-moo, man. Don't be like me. You don't want to have this face. No, don't do that. That's evil. After the clay and the block collide, block A lands horizontal distance dA from the edge of the table. Does block B land on the floor at a horizontal distance from the edge of the table that is greater than, less than, or equal to? In a clear coherent paragraph length response that may also equate equations or drawings, explain your reasoning. Neglect any frictional effects due to the table under air resistance. Oh, I already know the answer to this. It's that this one, it's so first of all, whichever one has the higher speed afterwards is going to have the greatest part there. So that's what the question is really asking. Which one has the higher speed? So if the clay and the ball have the same mass and these two have the same masses, as I said before, this one, it's going to rebound. So because it rebounds, it has a greater change in momentum. If it has a greater change in momentum, therefore it has a greater impulse, which means that the impulse on this one will be greater, which means that this one, block B, will be flying further. See, a lot of kids get mixed up with that, so I'll do the quick math here. The quick math is that your impulse, which is just, I think the symbol is like J is equals to the change in momentum, but the change in momentum is the mass times the final velocity minus the initial velocity. So, broski, look at it now. This thing, the final velocity is like negative, right? So if you take the right to be positive, then the final velocity is going to be negative. You see what I'm saying? Because it's going in the opposite direction. It rebounded. So, or if you want to take the right to be negative and the left to be positive, doesn't matter. You're going to see that what you're going to end up with is either you're going to end up with a negative V minus a negative V0. So these two things would be added together. You see what I'm saying? If you switch the directions of the thing, then these two things would be added together same way. So you have a greater impulse. So because you have a greater impulse and both things are experiencing the same impulse, then this one was going to have a greater velocity afterwards. It's kind of weird, but it is true. Because the fact that the ball had to change direction, then the impulse would be greater. So the next ball, the block will have a greater impulse. You could even work the math out if you want. You see what I'm saying? Because the impulses are equal, and then if you do that, then you're going to put that, then you're going to see that its change in velocity is much going to be greater than the other change in velocity. You smell what I'm cooking? But the rock is cooking. I'm not a rock. Oh, and that's it. Oh my God, that was easy. Oh, clutch. Let's go. Hopefully I'm not wrong on the first one. All right, with that, hey kids, don't be a moo-moo.